Namaste, Rakesh Tripathi. Today's topic trigonometric function, trigonometric equations. This is the 11th standard topic Cbse board. In previous lecture, I finished exercise 3.3. It's very important to understand exactly what is a trigonometric equation. Everyone know, you people are familiar with the equations, y equal to 2 equation, x plus y equal to 5 equation, a plus b equal to 7 equations. So this is the trigonometric equations, means sin x, equations which involve trigonometric functions of unknown angles are known as trigonometric equations. Sin x equal to 1 upon 2 trigonometric equations. Solution of the trigonometric equations. A solution of trigonometric equations is the value of the unknown angle that satisfies the equation. A trigonometric equations may have an infinite number of solutions. There are two types of solution. We are going to learn how to write the solution of the trigonometric equations: principal solution and general. Principal is what? The solution of the trigonometric equation for which x greater than or equal to 0 but less than 2 pi are called principal solution. General solution is what? The expressions involving integer n which gives all solution of the trigonometric equations is called general solution. I have written some results. There are total 3 types of results. I have written sin theta equal to 0, then what is the value of theta and pi. Cos theta equal to 0, then theta will be equal to 2n plus 1 pi upon 2. Tan theta is equal to 0, so theta will be equal to n pi. Similarly, sin theta is equal to sin alpha, then theta will be equal to n pi plus minus 100 for n alpha. And then sin square theta is equal to sin square alpha, then theta will be equal to n pi plus minus alpha. So there are total 3 types of results I have written over here. Now I am going to show the proving part. Theorem number 1: if sin theta equal to 0, then theta will be equal to n pi. How? If sin theta equal to 0, then theta will be equal to 0, pi, 2 pi, plus minus pi, 2 pi, plus minus 3 pi. Means sin theta equal to 0, then sin 0 will be 0, sin pi will be 0, sin 2 pi will be 0, sin 3 pi will be 0. So theta will be equal to what? N pi. Means the value of n belongs to integers. Question number theorem 2: sin theta is equal to sin alpha. Then transpose sin alpha to the left hand side. Sin theta minus sin alpha. Now apply the identity. Sin theta minus sin alpha. Sin c minus sin d. 2 cos c plus d by 2 sin c minus d by 2. So 2 cos theta plus alpha upon 2 equal to 0. And sin theta minus alpha upon 2 equal to 0. So cos theta plus alpha upon 2 equal to 0. And then you can apply cos theta is equal to cos 0 identity. Theta plus alpha upon 2 is equal to 2n plus 1 pi upon 2. 2 and 2 get cancelled. Theta plus alpha equal to 2n plus 1 pi. And theta will be equal to 2n plus 1 pi minus alpha. Similarly, sin theta minus alpha upon 2 equal to 0, and theta minus alpha upon 2 equal to n pi, theta minus alpha is equal to 2n pi, and then theta will be equal to 2n pi plus alpha. Third one, sin square theta is equal to sin square alpha. Substitute the formula for sin square theta. 1 minus cos 2 theta upon 2 equal to 1 minus cos 2 alpha upon 2. 2 get cancelled. Cos theta 2 theta is equal to cos 2 alpha. Then 2 theta will be equal to 2n pi plus minus 2 alpha, and then theta will be equal to n pi plus minus alpha. N belongs to integer. Question number 1: if tan x is equal to root 3, then write down the general solution and principal solution of the given equation. So tan x is equal to root 3, you can write tan pi upon 3. Means right hand side you have to convert in terms of tan, so that we can equate angles, so that we can write the value of x. Tan pi upon 4. The same thing, tan pi upon 4, you can write tan pi plus pi upon 3. Tan pi plus pi upon 3. Tan 180 plus theta will be tan theta, third quadrant. So pi plus pi upon 3 is what? 4 pi upon 3. So principal solution will be equal to what? Pi upon 3 and 4 pi upon 3. If you want to write the general solution, then tan theta is equal to tan alpha, then theta will be equal to n pi plus alpha. Alpha means what? Pi upon 3. So n pi plus pi upon 3 n belongs to integer. If you put n is equal to 0, you will get pi upon 3. If you put n is equal to 1, you will get 4 pi upon 3. If you put n is equal to 2, you will get 5 pi upon 3, 2 just 6 plus 1, 7 pi upon 3. Means just put the value of n integers and you will get the principal solution of the given equation. Sec x is equal to 2, we have to simplify. So cos x is equal to 1 upon 2. Sec cos is what? Reciprocal of sec. So sec x is equal to 1 upon cos x is equal to 2. So cos x is equal to 1 upon 2. Now cos x is equal to cos, convert right hand side 1 upon 2 in terms of cos, so cos pi upon 3. So cos will be plus in the fourth quadrant and first quadrant. It will be plus. So pi upon 3 you can write 2 pi minus pi upon 3. Fourth quadrant is what? 360 minus theta. 270 plus theta and 360 minus theta. So 2 pi minus pi upon 3. So 3 to just 6 pi minus pi 5 pi upon 3. So pi upon 3 or 5 pi upon 3. This is the principal solution of the given equation. General will be 2n pi plus minus pi upon 3. Now third, cot x is equal to minus root 3. So tan x will be equal to minus 1 upon root 3. Reciprocal. Tan x is equal to, now convert right hand side in terms of tan, minus tan pi upon 6. So tan x is equal to tan pi minus pi upon 6 or tan 2 pi minus pi upon 6. So 6 pi minus pi, 5 pi upon 6, 6 to the 12, 12 minus 1, 11 pi upon 6. So principal solution will be 5 pi upon 6 or 11 pi and 11 pi upon 6. The general solution will be equal to n pi plus 5 pi upon 6. If tan x is equal to tan theta, then x will be equal to n pi plus theta. Theta means 5 pi upon 6. Question number 4, cosec x is equal to minus 2. So sin x will be equal to minus 1 upon 2. Sin x will be equal to, now convert in terms of sin, minus sin pi upon 6. So sin will be negative in the third and fourth quadrant. So third is what? 180 plus theta. So sin 180 plus theta, so pi plus pi upon 6. And fourth quadrant 2 pi minus pi upon 6. So sin 7 pi upon 6 and sin 11 pi upon 6. Principal solution will be equal to 7 pi upon 6 and 11 pi upon 6, and general solution will be equal to n pi plus minus 100 power n 7 pi upon 6. Find the general solution. Question number 5, cos 4x equal to cos 2x. So you can transpose cos 2x to the left hand side. So cos 4x minus cos 2x. Apply the formula cos c minus cos 2. So minus 2 sin c plus d by 2 sin c minus d by 2. So minus 2 sin 3x and sin x. So sin 3x will be equal to 0 and sin x will be equal to 0. So it will 3x will be equal to n pi. So x will be equal to 10 pi upon 3 and x will be equal to n pi. Question number 6, cos 3x plus cos x minus cos 2x equal to 0. So cos 3x plus cos x, you can apply the formula cos c plus cos d, 2 cos c plus d by 2 cos c minus d by 2 and minus cos 2x. So now cos 2x common. So cos 2x common, so 2 cos x minus 1 equal to 0. This implies that cos 2x is equal to 0 or cos 2 cos x minus 1 equal to 0. So cos x is equal to 1 upon 2, cos x is equal to cos pi upon 3. So here if you will write the general solution of the given equation, so you will apply that formula cos theta is equal to cos alpha. So theta will be equal to 2n pi plus minus alpha, alpha means 2 pi upon 3. And here you will get 2x is equal to 2n plus 1 pi upon 2, transpose 2 to the right hand side, so 2n plus 1 pi upon 4. Question number 8, sec square 2x is equal to 1 minus tan 2x. So convert sec 2x in terms of tan, so 1 plus tan square 2x, 1 get cancelled, tan square 2x plus tan 2x. Tan 2x common, so tan 2x plus 1. Now tan 2x is equal to 0 or tan 2x plus 1 equal to 0. 2x is equal to n pi, x will be equal to n pi upon 2. Tan 2x is equal to minus tan pi by 4. So this minus we have to remove from here. So tan will be negative in fourth quadrant and first quadrant. So first quadrant tan pi minus pi by 4. or tan 2 pi minus pi by 4. But we are writing here general solution, so we need this term only. Tan 2x is equal to tan pi minus pi by 4. So 2x is equal to 3 pi upon 4, x is equal to 3 pi upon 8. So 2x will be equal to 2x will be equal to n pi plus pi upon 3 pi upon 4. N pi plus alpha. Alpha means 3 pi upon 4. So x will be equal to transpose 2 to the right hand side, n pi upon 2 plus 3 pi upon 8. Miscellaneous exercise question number 1. Left hand side I have written, right hand side we have to prove 0. So apply the formula. See, there are total 3 terms are given. First term, second term, third term. In the first term you can apply 2 cos A cos B, that is the cos A plus B plus cos A minus B. So here we got cos 10 pi upon 13. Here we got cos minus 8 pi upon 13. Here we have cos 3 pi upon 13. So can we convert this also in terms of 3 pi upon 13? Can we split it? So I have written pi minus 3 pi upon 13. Cos 1 pi 13 pi minus 3 pi 10 pi means we need to split 10 pi upon 13. So pi minus 3 pi upon 13. So cos 180 minus theta minus cos theta. Second quadrant minus cos 3 pi upon 13. Already one more term given. Cos 3 pi upon 13. This part will get cancelled. This one cos pi minus 5 pi upon 3, again minus 8 pi upon 3, we can split pi minus 5 pi upon 13, 8 pi upon 13 we can split pi minus 5 pi upon 13, cos 180 minus theta, again minus cos theta. So minus cos 5 pi upon 13, cos 5 pi upon 13 get cancelled and it will be 0. Question number 2. Again cosine C plus sin D, 2 sin C plus D by 2. Just after applying the formula, both the terms are same with opposite sign. So result will be 0. Question number 3. Cos C plus cos D whole square plus sin C minus sin D whole square. Apply the formula. Cos C plus cos D, 2 cos C plus D by 2, cos C minus D by 2. Here sin C minus sin D, 2 cos C plus D by 2, sin C minus D by 2 whole square. 2 whole square 4, cos x plus y upon 2, cos x plus y upon 2 common. So cos square x plus y upon 2 common. So remaining parts will be cos square x minus y upon 2 plus sin square x by x minus y upon 2. So cos square theta plus sin square theta 1. So right hand side is what? 4 cos square x plus y upon 2. Question number 5. Sin x plus sin 3x, sin 5x plus sin 7x. Apply the formula sin C plus sin D in both parts. So 2 sin C plus D by 2 and then common 2 cos x common, sin 2x plus sin 6x, again apply sin C plus sin D. So your result will be 2 cos x, 4 cos x, cos 2x and sin 4x, right hand side hence proof. Question number 8, nice question. Find the value of sin x upon 2, cos x upon 2 and tan x upon 2. Tan x given minus 4 upon 3, x in quadrant second, x lies in the quadrant second, and we have to find the value of sin x upon 2. This is what x given. So divide by 2. So x upon 2 greater than pi by 4, less than pi by 2. Now it will lie in the first quadrant. So first you find the value of cos. To find the value of cos, we can apply this formula, sec square x equal to 1 plus tan square x. Put the value of tan x, 25 upon 9. Sec x is equal to plus minus 5 upon 3. Cos x is equal to plus minus 3 upon 5, reciprocal both sides. Now cos x is equal to minus 3 upon 5. Why? X lies in the second quadrant. Second quadrant, cos and sec, sin and cos x plus, the rest will be minus. That's why it will be minus. Now we have to write the value for cos x by 2. So cos x will be equal to 2 cos square x by 2 minus 1. So you can put the value, we can put the value of cos x, cos square x by 2 will be equal to 1 upon 5, cos x upon 2 will be equal to plus minus 1 upon root 5, but this will be plus. X upon 2 will lie in first quadrant. Look at here, greater than pi by 4. Pi by 4 means 45 degree and less than 90. So first quadrant. Okay, so it will be 1 upon root 5. Similarly, now find the sin x upon 2. So apply the formula sin square x upon 2 plus cos square x upon 2 equal to 1. Cos square x upon 2, 1 upon root 5. So square, so 1 upon 5 minus 1 minus 1 upon 5, 4 upon 5. So sin x upon 2 is equal to 2 upon root 5. Again, this will be positive. First quadrant. All trigonometric function will be positive. Tan x by 2 sin x upon 2 upon cos x by 2. And this 2 upon root 5 upon 1 upon over 1 upon root 5. So it will be equal to 2. Thank you so much.